Hi everyone, welcome to this tutorial on the AP Model Manager plugin for Nina. I'm Brian Valenti. I've created this plugin as a personal project, and today I'll walk you through how to use it to automate your astrophysics sky model management within Nina. Just a little bit on the purpose of the plugin. If you're using astrophysics mounts with APCC Pro and sky modeling, you know how powerful sky models can be for accurate GOTOs and tracking. But if you're doing automation, manually loading or creating different models for different sky regions or targets can be really tedious and can really interrupt a fully automated session. So the AP Model Manager plugin solves this by automating sky model selection directly within your Nina advanced sequences. It can automatically select the best model based on your target's declination or create a new one if none matches, manage a database of your sky models, including model aging and renewal, and even set some model options. You can do this for multiple targets per night. The goal here is to automate modeling so you don't have to manually intervene ever. It's also a flexible set of instructions so you can adapt it to your approach. There's no one way on how to use this. If you use Nina and the AP Tools plugin for on-the-fly model creation, this is a great tool for you to increase that level of automation. Even if you use basic all-sky models or want to manually manage model selection, there are still some features and benefits to streamline things. Just a quick note again, this is a personal project of mine. This is not something from nor supported by Astro-Physics. Before we begin, let's make sure you have everything you need. This is a plugin for Nina version 3.0 or later. This plugin was developed and tested using Nina version 3.2. So the assumption is you're going to use Nina's advanced sequencer. It is not designed for the basic sequencer, and it has not yet been tested with the target scheduler, so unknown about that. But if you have a basic set of sequences or advanced instructions, this is a great way to add automation in there for sky model management. The assumption is also that you have an astrophysics mount and are using APCC Pro. You have astrophysics ASCOM driver also installed and configured, and that basically you're already using and have a working sky model system or approach using the astrophysics point mapper. This is going to automate what you already have. So if you're not already using sky modeling or it's not already working, you need to get that sorted out first, and then this will provide the automation around that. You also need the Astro-Physics Tools plugin from Dale Gant. This is for the model creation automation. This works hand in hand with this plugin, as you'll see. Installing the plugin is not currently done through the Nina plugins repository, but it is relatively straightforward to do it manually. You'll download the plugin via the link that's in the description of this video, and you will install it into the Nina folder, and I'm going to demonstrate that. Once you have the zip file downloaded, you're going to extract the contents of that onto your computer. And here is an example of that. The contents is just the folder, APCC Model Manager. And you are going to install this into the Nina plugins directory. This is typically here where you would insert your username instead of mine in the app data, local Nina plugins, and in 3.0. So all you do is you simply click and you drag this and you copy it into 3.0 folder, and then you're ready to go. And as you can see, I have it here. After copying the files, you restart Nina, and you should see in the plugins area the APCC Model Manager or AP Model Manager. So now I'm going to walk you through the configuring the plugin options. I just want to point out this home page isn't actually currently active right now. So first, we are going to configure the model storage location. This is the default folder for where astrophysics models are stored, so you don't need to necessarily change anything if you just went with the default installation for APCC. If you do have models stored somewhere else you would need to set that by clicking the Browse and choosing the folder where your models are stored. From that folder, the plugin will build a model database of all the model files in there. It will look for your .pnt files. The model database section shows how many models the plugin has found. You can click the Scan Now button, or the Refresh Now button rather, to manually refresh the database, but it is also automatic scanning, which will detect new models as they're created. So if you're creating new DECARC models or other types of models over time, it will actually pick those up and add those to the model database. The database then parses each model file to extract the metadata, such as declination range, point count, and creation date, amongst other things, to assist in automatic model selection. Next is the default all-sky model. That is your fallback model. So when automatic selection can't find a suitable model for a target, you can opt to use the default all-sky model, and you would click the Browse button to select the default all-sky model, and you would choose a point file. You can also automate creation and selection of what is the default all-sky model within the instructions, and we'll see that. The debug mode should not be used for automation. This pops up windows to debug and test things, so best to leave it off. The model matching criteria section controls how automatic model selection works. The model expiration days setting determines how old a model can be before it's considered stale and is no longer used. The default is 90 days, but again, this is really going to be something that is going to be specific to your setup. The target dec tolerance sets how close to a model's declination coverage it needs to be for your target. The minimum matching declination lines and minimum point count are additional criteria to ensure that you have a model that has at least some number of points. So for example, if it only solved 2, it would not use that. And the minimum number of declination lines. And declination lines will include not only the target declination, but above and below. And as you may also notice, there is a lot of tooltips for all of the various fields here. So a good starting point might be a target declination tolerance of 1. You want at least 3 lines and a minimum point count of, let's say, 20. But again, if you're doing smaller models or simpler models, you can lower that or increase that. Next is the extended criteria. So this is information that is taken from the Astro-Physics Point Mapper, or APPM screens, and also generated from the metadata from your PNT files. So it will actually show you information about the version, the mount type, username, and so forth, mount firmware. So for example, here, these are all the various versions of the mount types that I have. This list is populated from the PNT files that were scraped. So I have a lot of example files and therefore a lot of example mounts here. When you select one or any of these, you would have to enable this, and then it will automatically select based also on mount type. And this is just a string, so you can actually type in other information. Needless to say, if you're using the Astro-Physics Point Mapper for this information, you want to make sure to use them in some consistent way. So for now, I'm going to disable this, so none of these are being used. And I'm going to scroll down, and you can use test model matching. So you can type in a declination, such as, let's say, 34, and we can test the match, and you can see if there's any model matching available. Now, in my case, I'm using a lot of test models that are much older. So I'm going to put this up at 365 days just to show you how this works. We can click the test match. Okay, nope, still don't have anything matching, so I'm going to adjust this. I'm not suggesting you adjust the model matching criteria. I'm just trying to show how this works. But it will tell you the criteria, and then we can do a test match. So I'm not having good luck with just an example of 34 degrees declination. So I'm going to try something closer to maybe 43. We'll do a test match. And you can see that it's selected this model, and it tells you a little bit of information about the model itself. So of the valid candidates, there are 5 models, and it chooses the newest model if there is more than one found. And you can, of course, turn on the verbose output if you actually want to see all the information that it goes through about checking the various models and whether they were matching or not. Now we're going to move to the advanced sequencer and take a look at the AP Model Manager instructions. So you can find these in the instruction area. You can click this and open it up, and you will see all the various instructions here. And we're going to go ahead and walk through some of these. To demonstrate this, you're going to need a DSO instruction set. So I'm going to go ahead and just drag one of these out just by example. And I'm going to go ahead and configure this real quick for a target that we can use as an example. Okay, so we've added M51 as a target that has coordinates in there, and you'll see in a moment how we use the AP load model to automate things inside of individual targets. Before we do that, I want to demonstrate some features of dealing with all sky models in general. Before we do any of these things, we might, for example, have a option to do a model refresh. And this is really intended to be refreshing the all sky model. So if a model is older, and this is again specific to the default all sky model, so we'll look at that. This means, of course, you have to have an all sky model. So if it's older than a certain number of days, let's say 30 days, so it's older than a month, we can rerun this. And you can actually select, if you forgot to choose an all sky model, you can actually choose it here. If you haven't yet created or defined an all sky model, you'll need to do that first. And again, you can just use the Astro-Physics tools plugin to create an all sky model, or you can just create one directly using APPM. I want to point out that oftentimes it's good to have just even a simple all sky model of 20 or 30 points that helps to deal with things like polar misalignment and some basic refraction capabilities as a backup if you're primarily using DEC-ARC models. So if the model is older than a certain number of days, it will tell you here, of course, the default all sky model and the current model age. So it's going to skip these instructions. But if the model is older than this threshold, then it will run these set of instructions. And here is where the Astro-Physics tools come into play. We can open this up and we can drag out to create an all sky model. So it will open APPM, it will create the all sky model. Then at that point, you can do an additional instructions to then, once it's done, to set that model as the default all sky model for the AP Model Manager plugin. So you can see how the two plugins complement each other and work hand in hand. And again, this might be a set of instructions that you use if you have a fallback all sky model, again, a very simple one, and just include it before all of the various deep sky objects or targets you're going to do for that particular night. So now we're going to look at kind of the meat and potatoes of the model manager. And this is typically within a DSO or your target. So within the target, you're going to have a set of instructions. And again, the instructions are aware of the target. So we are going to pull out our AP load model. And this is the workhorse instruction here. So you have a number of options in terms of how the model mode works. Disabled just skips it over. So for example, later on, I'll show you there are options to change the AP load model mode. And so you can actually run a model and then skip it later. The very simple example here in a non-automated way is just simply to manually select a model that it will load. So you can choose a model file, for example, this one, and it will load that model. And if for some reason the load model fails, you can actually do something such as creating a deck arc model. I'm going to get into this a little bit more in the next section or the next mode rather, but for now I'm just going to delete that and just show you there's an option to manually select a model to load. Automatic selection is really where the magic kind of happens. So all the plugin settings and everything that deal with your various models that already exist or are going to be created for you in the future are done through this automatic selection and all the criteria we saw in the options page. So here, for example, the target declination is actually read from your target. This is a manual check of the button if you're curious if there's going to be an actual model that's selected. So yes, it will. So the automatic selection, if it finds a model that matches, it will load it and it will skip any additional instructions. However, if it doesn't find it, and again, I'm going to go back and use my example here. So I'm going to change that declination, and you can see the target declination here changes. No matching. So it will run the instructions in this container area here. So in the case of M51, it's going to attempt to automatically load a model. If it cannot find one that matches the criteria, it will run these instructions. So the typical instructions I would have would be something like creating a deck arc model. And again, this is all done through the AP Tools plugin. Once that's done, it will automatically load that deck arc model as the active model in APCC. Now, next time this runs, the automatic selection will pick that up. So this is really all you need to do if you want to automate your modeling, both the creation of the models and the subsequent loading of the models later on. And again, you can specify whatever criteria you want so that if every night the model is expired, it will automatically rerun it. Maybe it's every 2 nights. Maybe it's specific to a mount type or a location. All these things can be configured in the options page to determine what is an automated model match. Now, if you happen to be using kind of a combination of all sky and deck arc modeling, you can also drag this down after it will run that model and set these options. Whoops, let me try that again. Here. And you can choose to enable or disable pointing corrections or make no changes, the tracking rate corrections, and whether deck arc tracking is enabled or not. So for a deck arc model, I would probably turn off the pointing correction, and I would enable the tracking correction, and I would enable deck arc tracking algorithm. Later on, at the end of the night, we can change these back to whatever the defaults are that we want, or if we switch to an all sky model, we may want to enable pointing corrections and tracking corrections, but disable deck arc tracking algorithm. But that's totally up to you as to how you want to use that. Now, if you prefer, you don't have to create a model. It will run any of the instructions in here if the model is not automatically found and selected. So for example, we have the simple version of this, which will just allow you to select either a manual model. In the event here, again, it's embedded into the automatic selection, or we can just sort of go to use the default all sky model. And again, that is something that needs to exist before. So again, up here, if we refreshed or selected our all sky model here, then that model will be used down here in the event that an automatic model selection did not work here. Again, just another way of how to go about using this. And you can intersperse them. So in some cases, some models, or some targets rather, you're going to want to use a custom deck arc model. In other cases, maybe it's a wide field and you just want to stick with the all sky model. So now I've loaded an example sequence that's a little bit more sophisticated and a little bit more thorough in terms of the ways in which you could use this. So in my sequence startup, we're going to wait for nautical dusk. And then in the startup, we're going to connect all of our equipment. We're going to open the flat panel cover. We're going to cool the camera. And then we wait for astronomical dusk. And again, in this case, I'm going to refresh the all sky model if need be. So this is kind of before we get going on the imaging, right after astronomical dusk. Again, total optional idea of using a fallback all sky model, certainly not a requirement. So now we are going to move on to the individual DSO targets. I've created 3 here just to show you an example. These are kind of later in the night. The B5 cluster is sort of earlier in the night, and then at the start of the night, VDB 18 is the closest. So very typical example here. So for the first target, we have, and again, this is just an example, but we have an instructions, target prep, and then target imaging. So in the target prep section, we are going to, in this example, just load my default all sky model. That's all we need to do. Again, if it doesn't load, we'll create an all sky model, and then we'll set that as the default all sky model. So this model will not only be created and it will be active, but in the future, it will now be set as the default all sky model. So for this target, we are just simply doing an all sky model and ensuring one that exists. We're going to unpark the scope. We're going to slew and center. We're going to run autofocus and then move on to the target imaging. That part is not critical for explanation of this plugin, but at this point, we actually have a all sky model that we know is going to work and is fairly recent. So I'm going to scroll back up and let's collapse this. And now we're going to move on to the Beehive cluster. This is the next target. So this is one that's more of a deck arc model type of example here. I don't know why this is in there, but so now we're going to do a load model automatic selection. And again, this is in my target prep. So target prep, target imaging again. So in the target prep, the automatic selection, and we're going to open this up, and we can see that it has a certain target declination, and that if that fails, we are going to create a deck arc model. We are going to set our model options, disable pointing corrections, enable tracking rate and deck arc tracking. Now at this point, what I've done also is opted to then switch this model, this AP load model, from automatic to manual selection. So in the future, it's just going to manually select this this model directly. And it's going to choose the current model, which is actually this model that we just created. Now I'm just going to click this button, Set Now, to show you how this works. So watch this up here. And when we click Set Now, this is how, whoops, well, that didn't work, but let me do this. I'm going to choose a model. So it'll probably work better. So again, watch this, Set Now, and you can see that it's manually selected in this model file. So in the event that it doesn't work, it will, again, go back to creating a deck arc model. But this is an example where you can move from automatic selection to a manual selection. Now, you may ask, well, why would I do that? Wouldn't I just stick with the automatic selection and just have it automatically check and create a new one? Yes, basically, that's the idea of how you want it to work. But these are different options for the ways in which you can configure and use it. So let's collapse this down. And now we're going to move on to M3. Again, we have our last target for the night. This is our target preparation area. So we are going to do the automatic selection. And again, it will automatically pull the declination in. If it doesn't work, we are going to, again, create a new deck arc model, set the options as we chose. Now, in this case, we can actually just remove this, and that's all that we need to do. This new deck arc model will automatically be loaded when it's finished. And then the next night, when we do automatic selection, assuming that it's still a valid setup, you haven't, moved the telescope or so forth, it should automatically select this target declination model that we just created. So then we're going to, of course, slew and center, run the autofocus, and so forth. So you can see at this point, if we have basic AP model instructions that are set up using the automatic selection, it will automate model selection, model creation, and subsequent model selection for future nights. Then at the end of our night, we're going to do a basic sequence end. I may have reset my model options to enable pointing correction, maybe tracking corrections, and turn off deck arc tracking if you want. Just briefly, I want to go back to the model matching criteria and specifically the extended criteria here. So a lot of this information is taken from the point mapper in this general information area. So this is not typically something that people use for a particular purpose, but if you are going to be using these advanced or extended criteria, you're going to want to start thinking about how to set these up and use these more purposefully so that you can distinguish between them. So I've had examples where people have wanted to change model based upon the site location or based upon the telescope. So they're going to image on one telescope, like the 130, and then they're going to switch and do the 155, and they want a different model for that. So just a quick example of how the point mapper fields here relate to this extended criteria information. So I hope you find this tutorial helpful. I hope you find the AP Model Manager plugin helpful. It's actively being improved, and I'm always looking for ways in which I can understand and help streamline your imaging automation. So if you have any bugs or feature requests or just want to share how you're using the plugin, please reach out through the comments below or in the Astro-Physics community's forums.